pathways because that's really what this section is still dealing with. Identical. We're still in the same section, but it's a little different. Okay, so when asked how many different pathways from point A to point B, it is a permutation question dealing with identical objects, right? So we're still dealing with identical objects. Okay, movements to the side, east or west, are considered identical. Movements up or down, north or south, are considered identical. There are two methods you can use to solve pathways. Okay, I would encourage you to know how to do them both, because then you can always verify if you got it right. Okay, method one, using the formula. So this is the formula, guys. There's a typo. I just got these booklets this morning. I begged them to send it to me earlier. So there's a typo here. And this is going to be bad. Because this needs to be on the top and this needs to be at the bottom. Like it's exactly flipped. So I don't know what you need to do to make this happen. Let me see here. Let me see. I think there's a blank page somewhere. But it's too far away. Good thing I caught it though. Can we do this? Wrong formula. See page 38. Okay. I actually solved the whole thing using, like, I know what the formula is supposed to be. I don't know how this happened, but I apologize. So let's go to page 38 and write down the correct formula. So let's do this. Pathways on page 38, okay? Total blocks traveled factorial divided by, how did I word it there? Oh yeah. Vertical blocks factorial divided by horizontal. That's the correct formula. You're the first group that I make booklets for, so that's a bit of the downside of being the first, but at least you get a booklet. I think it's nice not to write the whole thing down, if you ask me. Some of you just did the arrow thing on that other question probably and are not going to bother writing this down, but to just make sure you have this on your study sheet, not the other way around. And you should recognize this, guys. Remember, when we do repetition, there's always the total right at the top divided by repetition, right? So that's kind of like the same pattern. That's how I right away, I looked at it and I'm like, that's wrong, right? So vertical blocks, I hope you know vertical and I hope you know horizontal, but hey, if you need a reminder, that's what I mean by that. Okay, I'm going back to here. I'll make a little note, so I'll just do this. I don't know. I don't want you to even, not even by mistake, get that one on your study sheet, right? Because then you'll blame me. You can't anymore. Anyways, method one is using that formula. Method two is using the counting method, and I'm just showing you the examples. Let's explore the cases here. So let's say you're traveling from, make a big point here, point A to B. That's where B is obviously your final destination in this case. And this is what we're assuming in this case. we travel north to south, and we only go west to east, right? So how about this here? Just a little reminder about north and south, right? And west, east. Okay. So in this case, we're only traveling this way, north to south, and horizontally, we'd only be traveling towards the right in this particular example. So if you're going from this intersection to that intersection, there's only one way to get there. If you're traveling from here to this intersection, because you can travel south or you can travel east, right? There's only one way to get there. You're following? So these numbers are attached to the intersection, telling you how many ways you have to get there. Now, let's say we want to go to this intersection here. You can go this way and down, or you can go down and then sideways. So how many options do you have to get here? 2. So basically what you do is you just add this one with that one and then put the number down. This is 2. Okay. And let's fill this out more. So this is in general, what you will be doing is when you start here, you put a 1, and a 1. All these intersections, only one way to get there. Same with going straight south. To every intersection, there's only one way to get there. Along that line. Along that line, there's only one way to get there. There's no other path you can take. And then you fill in the intersections inside of this box. So it's 1 and 1, 2 to get to here. To get to this intersection, you have more options now. You're going to take the 2, add the 1 to it. You actually have 3 ways to get there, to this intersection. So you could go 1 way, you could go 2, right? You could go 3. There are 3 ways to get to this one right here. And then you keep adding. 3 plus 1, there'd be 4 ways to get to this intersection here. And then you go back down 1 block. You repeat that. 1 plus 2. There are 3 ways to get to this intersection here. 3 plus 3. There would be 6 to get to this intersection right here. 6 and 4. There's 10 ways. That's the one that we're after. There would be 10 possible ways to get to B. And you're like, really? Yeah. So this is method 1. Method 2, sorry, counting. That's how I did here. Method 1, I like to show you method 1 after I've done this thing. So you go paths, right? You traveled, let me get a highlighter for this one. How many blocks could you travel in total? So it doesn't matter if you go this way or that way, but you basically just start. It's like 1, 2, 3, 4, 5. Like in total to get from A to B would be 5 blocks. You factorial that. Over. I will highlight that 5 like that. And my other examples, I will go the other way. I will go down and over so you see it's the same thing. Now, it doesn't matter which one you do first, but underneath this, I will say there's 1, 2, 3 boxes horizontally between A and B. Factorial that. And I will use yellow. Maybe I'll use orange. Then this way, there's 1, 2 blocks vertical. Factorial that as well. So 5 factorial is 120. 3 factorial is 6. 2 factorial is just 2. So this is 120. What's 6 times 2? You can do that. You can do it. You can do it, right? 10 ways. This should match. If your answers, right, should match. If they don't match, oops, you made a mistake, right? So you should be able to use the formula, you should be able to do the counting method. Sometimes the counting method is a bit difficult to do, and students prefer the formula. I want to explain to you why this is happening. If you think about it, let's go back to words. If you're going from A to B, how many steps would you go east? You would go E, 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 right? E, E, E. And how many steps would you go south? 2, right? So if I asked you to arrange the letters in this word, there are how many letters total? 5, right? But you notice that there are 3 E's and 2 S's, and so you divide that out. So this is very much still related to that concept of rearranging, because if I said, hey, rearrange this, let's give them a sub 1, right? Hey, let's go a different way, right? Go east, that 1 east, and then put the 3rd east here, and then the 2nd east there, right? And keep the south paths the same. This is the same arrangement, same permutation. Okay, so we divide out the repetition. Okay, let's go another one here. Let's do our total first. You're going from A to B, right? In this case, you're going from down here up to B. So it's still the same steps. It's just you're traveling this way and up. Okay, you're going south to north, and you're going west to east to west. Can you change that, please? You're going east to west. That's the only way you can travel for this to work, right? And that is always an assumption we make. So let's get our total. You can go 1, 2, 3, 4, 5, 6, 7. There will be 7 paths. It'd be 7 factorial, and that's the pink, right? Divided by, what did I use for horizontal? Green. So I'm going to stick with it in this one. So there's 1, 2, 3, 4. 4 factorial for horizontal travel, and there's 3 factorial for vertical travel, right? And I will highlight that in a bit. Let me just get my highlighters arranged here. 1, 2, 3 for vertical. And it doesn't matter if you did vertical and then horizontal. It doesn't matter. You get the same answer. So that would be 7 factorial is 5,000 something. I always forget that one. 50, 40. This is 24, and this is 6. So it's 50, 40. Divided by 24 times 6. That's 35 ways that you could travel. And I'm running against time here. So let me just do this real quick. If you start here, you start at this intersection. It's 1, 1, 1. Along the outside, there's only one possible way to get there. Right? and then you just start, you basically go the other way. You add and then put the 2 here. 2 and 1 is 3. 3 and 1 is 4. 4 and 1 is 5. Go up another row. 1 and 2 is 3. 3 and 3 is 6. 6 and 4 is 10. 10 and 5 is 15. Okay. Go up a row. 1 and 3 is 4. 4 and 6 is 10. 10 and 10 is 20. 10 and 15, 35. Boom. That's what you wanted, right? The 35s are matching, so you're good to go. And practice will make you good at this. I need to do one more before we go today. We're going to step it up a notch. Look at all that highlighting. It's just so pretty. So pretty. Okay. Case 2. We'll do case 3 tomorrow. But case 2, going through the middle point. Like, what if there's a bottleneck? I call that. This is your bottleneck right here. Okay. Determine the number of ways you could travel from point A to C. Use both methods. I will do this. What you need to consider here is, look up the top here. You're going to go from A to B, right? And B to C. That's how you're going to travel. You're going to go from A to B and then B to C, correct? So what you need to do here is be careful. From A to B, how many steps can you take total from A to B? Let's do this. 1, 2, 3, 4, right? 4 factorial over, there's 2 ways you can travel horizontally, and there's 2 ways you can travel vertically. And you're like, oh, that's just going to cancel out. It's 4 factorial over 2. No, not so fast, right? Not so fast. Hold your horses. What does AND mean in math? OR is adding. This is multiplication, right? So you're going to have to multiply. There's another way, another stretch you need to take into account. How many steps can you travel total? 1, 2, 3, 4, 5, 6. So 6 factorial over. There's 4 horizontal steps you can take, 2 vertical steps you can take. So you should be able to see that they add up to the top, right? When you're doing pathways. And so that is now 4 factorial is 24 over 2 times 2 is 4, right? We'll still, oh, it's tight, okay. 6 factorial is 720 over 24 times 2. Okay, so at this point, how about 24 divided by 4 is 6. 720 divided by 48. I will quickly do that, that's 15. 6 times 15 is 90. Just making sure. 90 ways. Can you do, like, we have 2 minutes. I just want to show you on counting method. You still do the same thing. 1, 1, 1, 1. So it's 1 and 1 is 2. 2 and 1 is 3. 1 and 2 is 3. 1 and 3 and 3 is 6. Hold it. What happens there? You have a bottleneck. What do you think is going to go along the top here? 6, right? It's going to be all along because to get to this point, there were 6 ways, right? And then 6 and 6. 6 and 6 is 12, 18, 24, 30. 18, what's 18 and 18? 36. That's 60. 60 and 30, 90, right? It matches. So it's just the bottleneck where you kind of have to, whatever you end up with here, you transfer that over to the sides and you continue. More tomorrow. I will ask you to do this. For now, try just this bottom page, this one right here. So this is homework. Try to apply the same reasoning we just did. And the rest we'll do more tomorrow. I might give you one AC with one question like this on there, okay? Thank you, guys.